Good morning, dear students. In yesterday's important topic, we have discussed audio video through important and various types of examples on the basis of electrolysis. Now, in today's lecture, we will discuss a new criteria. The criteria, which type of criteria we will discuss in today's lecture. Now, we will explain this. But before starting this topic, first I will introduce the topic of today. Just see, we know that in electrolysis process we need very important electrolyte solution. But we know again important point that there are two types of electrolyte, strong electrolyte and weak electrolyte. What is strong electrolyte? Complete ionization of substance, it is known as strong electrolyte, while incomplete ionization of substance is known as weak electrolyte. But if we are discussing about strong and weak electrolyte, which type of compound is more needed for electrolysis process? So the answer is strong electrolyte. It is very important because it is strongly ionized in water. But now see the other side of strong and weak electrolyte. In physical world, we can say that if we have strong electrolyte, then there is less resistance in strong electrolyte because all the ions will obtain or will occur from electrolyte compound. While in weak electrolyte, there will be much more resistance will obtain because it is not completely ionized. So the reason is clear that in strong electrolyte the proportion of resistance is low, while in weak electrolyte the proportion of resistance is high, strong. But before starting to explain that how can we measure the resistance, before that first of all we will understand the resistance. Okay, so the next question is here, that what is resistance? According to Ohm's law, the formula is here. Just see, formula of resistance R is proportional to L by A, and the symbol of resistance is R. R is proportional to L by A. What is L? So the L means length. A. What is A? Cross-sectional area. It is A. So R is proportional to L by A. This rule is given by Ohm. So the rule is Ohm's rule. That resistance is proportional to length, but it is inverse proportional to area. So R is proportional to L by A. If we remove proportional to symbol, R is equal to rho into L by A. Rho is proportionality constant. It is known as resistivity. Students, just remember the formula of all this type of physical definitions, physical words. This is resistance, and the unit of resistance is, we know that, very simple, Ohm. Clear? Our speed breaker which we are using for doubts. So the unit of resistance is Ohm. So the first phenomena is here. It is resistance, but what is the reason behind this that we are discussing resistance here? The reason is crystal clear. In strong electrolyte there is lower resistance, while in a weak electrolyte the resistance is high. So this is the definition of resistance R, proportional to L by A. Okay, this is number one point. Point number two, which is resistivity. Resistivity rho. Very simple. Now we will subject rho from this formula, rho is equal to R into A by L. Just see, A will go on the left side, R into A, L on the left side upon R into A by L. Now the unit of resistivity is, unit of R is ohm, area meter square, length meter, meter cancel, ohm into meter or ohm into centimeter. In the other word, mho inverse into meter, while mho inverse into centimeter, mho into meter, mho inverse into meter, mho inverse into centimeter, MHO. Is it clear? But what is resistivity? So exact length and exact area, and this is resistance R A L. So if any substance having exact length and area, it has resistance. This is known as resistivity. Very simple definition. Rho is equal to R into A upon L. Clear? R is equal to rho into A by L, L by A. So rho is equal to R into A by L. એમાં મેં ક્યાં ડિફરન્ટ વાત કરી છે? ઓલામાં R ને સબ્જેક્ટ હતો, આમાં rho સબ્જેક્ટ છે, કઈ નવું છે જ નહીં. Ohm into meter, ohm into centimeter એનો યુનિટ છે. This is resistivity. Okay. Now, the next important point after resistivity, third one, which is conductance. The symbol for conductance is G, but very simple definition is here. Inverse of resistance, inverse of resistance is conductance. 1 upon R is equal to G. So the unit of conductance is conductance or conductivity. જે બી આવે તે આનું યુનિટ 1 upon R એટલે ohm inverse or mho or SI unit. જો આપણો આનો દર્શક બતાવો હોય SI unit તો થશે Siemens. So SI unit of conductance is Siemens. So inverse of resistance is known as conductivity or conductance. G is equal to 1 upon R. This is the third important definition is here. Fourth one, it is specific conductivity. Specific conductivity, symbol of specific conductivity is K. Greek language, kappa, not papa, kappa is specific conductivity. Okay, so definition, just see, define and formula. K is equal to 1 upon rho. So the inverse of resistivity, inverse of resistivity is known as specific conductivity. Inverse of resistivity, inverse of resistance, it is conductivity. Inverse of resistivity is specific conductivity. K is equal to 1 upon rho, and the unit of 1 upon rho is here. Just see, rho માં શું છે? ohm into meter. So 1 upon ohm into meter. So we will write ohm inverse, meter inverse, ohm inverse, centimeter inverse, mho meter inverse, mho centimeter inverse, Siemens meter inverse, Siemens centimeter inverse. These are the various types of units of specific conductivity. Now in a section of specific conductivity, just see, if we subject this rho here, but before subject rho, we will put the value of rho here. This is equation number 1. Equation number 2. Put equation number 1 into 2. 1 into 2. Okay. So K is equal to 1 upon rho. Instead of rho, we will put R into A by L. So R into A by N. A by N એટલે N છે ઉપર જશે. So K is equal to just see 1 upon R means G L by A. This is the formula of specific conductivity K. Kappa G into L by A. Means this is specific conductivity. Specific conductivity. This is conductivity G into L by A, the name which is used for L by A, it is cell constant. Remind this important point. L by A is equal to cell constant. Now what is the unit of specific conductivity? Unit of G is Siemens. Unit of G is Siemens. Here again we will prove this unit Siemens. L by A. L by A means meter upon meter square. Again Siemens meter inverse. Is it clear to all? So G into L by A, Siemens into meter inverse, it is the unit of specific conductivity. This is fourth important point. Just see again, I remind you all. Resistance R is equal to rho into L by A. Resistivity rho is equal to R into A by L. આ ઇન્વર્સ જ છે બે. હવે રેઝિસ્ટન્સ નો જે ઇન્વર્સ છે, રેઝિસ્ટન્સ નો જે ઇન્વર્સ છે એને આપણે શું કહેવાનું થશે પછી? એ રેઝિસ્ટન્સ ના ઇન્વર્સ ને આપણે કહેશું કન્ડક્ટન્સ અને રેઝિસ્ટિવિટી ના ઇન્વર્સ ને આપણે શું કહેશું? તો કે સ્પેસિફિક કન્ડક્ટન્સ. These are the various type of definitions. Fourth one and the fifth and last one, it is molar conductivity. The symbol of molar conductivity is capital lambda. Just see, આ આપણે જે ઇન્વર્સ v જેવું લાગે છે ને એને રીડિંગ કેમ કરે ખબર છે? કેપિટલ લેમ્બડા. શું કહેવાનું થાય? કેપિટલ લેમ્બડા. Just see the formula of molar conductivity. આની ડેફિનેશન શું કામ જોવી પડે? ઇટ ઇઝ વેરી ઇમ્પોર્ટન્ટ. કેમ? આપણે હવે કેમિસ્ટ્રીની અંદર રેઝિસ્ટન્સ મેઝરમેન્ટ કરવો હોય તો ફિઝિક્સ થોડું છે કે આપણે પેન હોય એના લેન્થ માપી લઈએ, આપણે એનું મેઝરમેન્ટ કરીએ. કેમિસ્ટ્રીમાં તો કેમિકલ હોય તો એની કન્ડક્ટિવિટી કેવી રીતના મેઝરમેન્ટ થાય એ હું તમને સમજાવીશ. એક્સપેરિમેન્ટ છે. બટ જસ્ટ સી હિયર, capital lambda into m is equal to 1000 into k upon c. 1000 into k upon c, where 1000 is used because concentration, if it is in ml, then we will use 1000. K, we know that specific conductivity. C means concentration, either it is in normality or it is in molarity, then we are using this important point, 1000 into k by c. The 1000 milliliter, that means centimeter cube. Concentration which is in normality or molarity, unit of K, Siemens upon centimeter. So the unit is Siemens centimeter square. The unit is molarity, means mole, because we are using here milliliter. So mole inverse. This is the molar conductivity, Siemens centimeter square into mole inverse. This is our molar conductivity, capital lambda into m, 1000 into k by c is a formula for this point. Is it clear? So these are the 5 various types of points: resistance, resistivity, conductivity, specific conductivity, and molar conductivity. All these formulas we will prove with the help of proper experiment. So don't worry about this point. We will explain this time again, but next time that will be on the basis of experiment. Okay, just see, એક વખત તમે બોર્ડ ઉપર જોઈ લ્યો અને હું તમને ઇમેજ સેન્ડ કરું છું.